Hi, and welcome to another question from the Best of XAT series. In this question, we are going to have a look at functions, algebra, graphs, whatever you want to call it. So what I would suggest is you have a look at this particular question, try it out on your own, and then have a look at the solution that will follow. If you are going to take the XAT and are wondering what exactly to do over the next few days, we have a very special video for you in which we have discussed the pattern of the test, the sectional cutoffs, the preparation strategy and the attempt strategy. You can visit the video by clicking on the I button above or from the link in the description box below. Happy learning. Now this is a very nice question in which you have a very good application of drawing graphs of polynomials. So if you would have seen some questions from the Best of XAT algebra series, you would be able to relate to this question in a better manner. And for all of those of you who are graph junkies, you will find it very easy to solve this particular question. So let's get going and let's see what exactly happens to this question. So one obvious way of solving this question is by plugging in values and checking what exactly happens. So if you put x equal to 0, x equal to 1, x equal to 2 and so on, you will see that the resultant is always going to be a positive number. What if x equals minus 1? Minus 1 plus 4 is going to be a positive number, and obviously minus 1 plus 6, minus 1 plus 8 and so on till minus 1 plus 98 are all going to be positive numbers. So it's going to give you the resultant as a positive number. What about minus 2? What about minus 3? It's going to give you the same eventuality. Minus 4 is basically where the entire product becomes negative, but we have to figure out for what values or what integers of integers x does fx become less than 0? That is the question here, right? So minus 4 will not work. What about minus 5? When it comes to minus 5 plus 4 is negative and all the other terms are positive. So if you have one negative term multiplied by so many positive terms, you are still going to get the resultant as negative. So minus 5 is definitely something that is going to be true in this particular case. What about minus 6? The entire thing becomes 0 if you put x equals minus 6, so not valid. What about minus 7? If you put x equals minus 7, the first bracket is not useful, the second bracket is not useful simply because both of them become negative. Now you have one negative number, another negative number, and all the other brackets will be positive. So two negative numbers multiplied by each other will give us a positive number, multiplied by a lot of positive numbers is going to give us fx greater than 0. So that will not work. What about minus 8? Will not work because it will become 0. What about minus 9? So minus 9 is basically where 3 terms become negative and the remaining terms will all be positive. So minus 9 should work. So minus 5, minus 9, if you try to extrapolate, minus 13 and so on. All these terms will be negative in nature. What is the farthest number that you can think of in this particular context which will satisfy this particular expression? So you can see that 5 leaves a remainder 1 when divided by 4, 9 leaves a remainder 1 when divided by 4, 13 leaves a remainder 1 when divided by 4. If you keep on going ahead till 98, you will see that there are so many terms that are present in this particular context. So if you count the number of terms that are present, you will see that there are 48 terms that are present in this entire sequence. So if you look at the largest or the farthest such number that we are looking at, you will see that it is going to be minus 97 that will be present. After minus 97, let's say you go to minus 98, the entire thing becomes 0. Minus 99, there will be 48 negative terms, and so the product has to be a positive number. So anything beyond minus 97 is not going to give us a negative response. So we have all these terms that will be present in this particular sequence. The question essentially becomes how many terms are present in this particular sequence. So what you can do is you can simply count how many numbers are there from 5 till 97 with a common difference of 4. Very easy question once you reach this particular conclusion. So if you look at what is the gap between these two numbers, you can say that the gap is minus 5 minus of minus 97, let's say, which will give you minus 5 plus 97 or 92. So the large gap that is present between the endpoints is 92. It is divided into smaller gaps of 4, which basically means that there are going to be 23 gaps. Now whenever you have 23 gaps, there have to be 24 numbers surrounding those gaps, because two gaps or two numbers rather will make one gap. So if I have minus 5 and minus 9, only then will I have a gap of 4. Minus 9 and minus 13, only then will I have 2 gaps of 4 each. So if I want to have 23 gaps, I need to have 24 numbers. That is one way of looking at it. The other way of looking at it is extremely easy, extremely straightforward. So I'll just show it to you quickly. So what we can do is, we can just try to draw this entire function on this number line. So we know that the smallest root or the largest root in this case is going to be minus 4. Then you have another root at minus 6. Then you have another root at minus 8, another root at minus 10, and so on till the time you reach minus 98. So each and every one of these points is going to be a root of this expression. Considering that the largest power of x is positive, because if you want the largest power of x, you are going to take x from each bracket, the product is going to have a positive coefficient. The value of the expression will start from here. It will cut the x-axis at minus 4, go to the other side, again cut the x-axis at minus 6, again go to the other side, and it will keep on doing this till the time it reaches the end. So we can see that for this number minus 5, it becomes negative. For minus 7, it becomes positive. For minus 9, it becomes negative, and so on. So we can simply say that minus 5 is basically one pair for which, or one number for which it assumes a negative value. Minus 9 is another number for which it assumes a negative value, and so on. Now considering that we have a minus 6 here, minus 10 here, and a minus 98 here. Again, if I want to talk about it in a slightly complicated manner, I am saying that 2 into 3 is 6, 2 into 5 is 10, 2 into 49 is 98. So we are going to have pairs of numbers that will be present. So for each pair 4 and 6, I will have one solution that will comply. For the next pair 8 and 10, or minus 8 and minus 10, I will have another solution that will comply. Considering that there are 48 terms in this entire sequence, how many solutions should comply? 48 terms, 24 pairs, that's why 24 solutions. So the correct answer is going to be option 3, even if you go through the approach of graphs. I hope you have understood how to solve this using graphs as well as by plugging in numbers and checking it. Obviously, as you go ahead, it's better for you to plug in or to look at the graph and try to figure out as to how exactly does this alternate skipping around the roots happens. And once you figure that out, it's very easy for you to solve this question even visually for that matter. So I hope you have understood the question. If you have any doubts with regard to the concept, please feel free to comment in the section below and we'll get back to you. Happy learning.